Warm-up number 28 is on the screen. Number 1 says solve x over 2 equals to 12 over 3. Numbers 2 and 3 is to factor. Number 2 reads x squared minus 3x minus 4. Number 3 reads 3x squared minus 3. And number 4, solve for y and graph using the domain -1, 0, and 1. Equation given, 3y minus 9x equals -12. So, as I said before, so it begins. Students graphing students. So I'm going to continue bringing in little components for the graphing portion of the school year. But after this, it's not going away. It's staying. Like the polynomials. Let's go. So I'll give you some time for that. Copy that and... Alright, here we go. Being that it's Monday, let me go over this real quick. So, first things first. We started with equations at the beginning of the school year, right? On the warm-ups, yeah? And then we did a review for these. What do we do when we have equations that involve fractions? We said we multiply the entire equation times what? Common denominator, yes? You guys remember that? Or, like these, when we have a fraction equal to another fraction, we can cross multiply. Watch. What is x times 3? 3x. What is 2 times 12? 24. And then we solve. Divide by 3. X equals 8. Copy that, please. And Raymond, you're over here behind Adrena. Alright? Number 2. By now you should be able to factor these in your sleep, right? Sometimes you wake up and polynomials, yeah? -4, -3, factors of -4 that add up to -3. -4 times 1 is -4. -4 plus 1 is -3, so my factors are x minus 4 and x plus 1. Hands if you got that? Number 3. This looks like difference of squares, but we can't take the square root of either. We need to check for what? GCF, which is what? 3x squared minus 1. Now this looks familiar, yes? Square root. So this is x plus 1, x minus 1, and don't forget the BSF. And have you got that? Okay? Alright. And of course, our graphing. Yay, let's go. Alright, let's see. Number 4. I need to solve for y first, so add 9x. Add 9x to each side. We're left with 3y equals 9x minus 12. Divide by 3, divide by 3. Y equals 3x minus 4. Hands if you got that. Okay. Now, since last week and the previous week, I've been working on getting you guys used to the table, yes? And you did x. This time I'm going to make it horizontal, -1, 0, and 1. And I need to get my range, which is y, all the values for y. So my first value I'm going to substitute in here is -1. What is 3 times -1? -3 minus 4, -7. Next, 0. What is 3 times 0? 0 minus 4 is -4. And last, what is 3 times 1? 3 minus 4, that's -1. Now, once we get into the whole graphing portion of the year, guys, the domain's no longer going to be just 3 numbers like here. It's going to be from -2 all the way to 2. That's most of our graphing bread and butter that we're going to use for domains. However, when we get to some of the graphing portion, I'm going to say, show me the work for when you get your table going. But after the 3rd number, if you see a pattern, use a pattern to fill in the rest without showing any work. So look up to the screen really quick. So some of you are like, pattern, what do you mean, Mr. Hugh? Well, look at this number, -7. Then it went to -4, from -4 to this number. Something's happening every step of the way. So if I was to ask you to input another value for x, tell your neighbor what the number would be there using that pattern. What would you do? What's happening every step of the way? Alright, I think Lenny's got it, and he told Pamela something. Well, Pamela, what's happening every step of the way? Adding 3, yes? So what is -1 plus 3? 2. That's how we get that next number, and so on and so forth. Yeah? Alright. Are we done? No, let's graph. Here we go. So to graph these points, what values do I need for x? -1, 0, and 1. So those are the only values I'm going to use for right now. -1, 0, and 1 of x. How about y? What values do I need for y? -7, -4, -1. So that means all the negatives, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7. That's -1, -2, -3, -4, -5, -6, -7. Alright? So what is my first point? -1, -7. -1, -7. Next one. 0, -4. And the last one. 1, -1. 1, -1. Then from there you sketch your line going through those points with arrows at the end, and there you go. Students graphing students. Welcome back, yes? Let's go. Alright. Copy the agenda for tonight. Here we go. For today, sorry. Warm-up number 28. We are moving on to subtracting of rational expressions. And our home plate for tonight is page 434. Now, I already uploaded that onto Canvas, but I'm also going to give you the code for Nearpod so that you can find that in there. Once again, today we covered warm-up number 28. We just finished. We're moving on to subtracting rational expressions. And tonight's home plate, page 434, all only. Okay? Alright. Here's your code for Nearpod, NBT8L, NBT8L. Once again, the PDF of page 434 is in there, but it's also on Canvas. So, without further ado, your home plate for the weekend, get that in front of you, take a picture, turn that into Canvas at this moment. And once again, tonight's home plate is 434. And for those of you watching online that are not part of our class, but you're joining us for the school year through the videos, just use the Nearpod code that was mentioned earlier so you can get the play sheet and work on that tonight. And get your Cornell note ready for today. We won't need a prayer model. I'll give you some time for that. Copy and go. Alright, here we go. Our objective for today, I can add and subtract rational expressions. As we covered last week, just addition. This week, today, we're going to focus on subtraction. Some of your favorite, right? Yay! No? Alright, do we need a prayer model? No, we already know what rational expressions are, right? Let's see. Rational expressions, in your own words. Tell your neighbor the definition of rational expressions in your own words. Rational expressions, what are they? Alright, good. I heard fractions with polynomials. Who said fractions is polynomials? Some of you, yeah? Look at them. Are they fractions? Yeah. Do they have polynomials? Yeah, that's pretty much a straightforward definition in your own words, okay? I gave the proper introduction to quotients, And then I give you guys steps to follow. Is that correct?
Yeah.
Today I'm going to be using the same steps, using the same color so we can keep it consistent. I'm going to use green for the first step, which is factoring the denominators completely and finding the LCD, or the common denominator. Black for rewriting it and adding and subtracting. Simplifying using the giant one in red. And at the end in blue, I'm going to do the excluded values as we continue. Everybody ready? All right, copy this. Example Q. It reads, add or subtract and identify the excluded values. Negative g over 2g minus 3 minus negative 3 over 4g minus 6. All right? So let's do this one together. You're like, really, Mr. Q? Yes. We know the process, yes? Here we go. So I'm going to start with step 1, which is factor the denominators completely. So look at the first denominator. Can we factor that anymore? No, that stays the same, so it's 2g minus 3. Minus. Look at the second denominator. Can we factor that one a little bit more? Yeah, Miguel, what would be our GCF? 2. That is correct, and we're left with 2g minus 3. All right, now we need to make sure we have a common denominator. So, look at it. They need to be exactly the same. So what do I do to the first denominator, Sky? Multiply times 2. That is correct. And what do we do to the denominator? We do to the numerator. Let's bring down the original numerators. This was negative g and this was negative 3. Negative g and negative 3. So we're done with step 1. Let's go to step 2. We need to rewrite that as one fraction. Okay? So my common denominator was 2 times 2g minus 3. All right? So now I focus on the numerators. Okay, writing utensils down really quick. Let me just show you the only difference between addition and subtraction. First, let me do this part. What is 2 times negative g? Negative 2g. Okay, so that's right here. Okay? However, look at this. Here's a negative, and this is a negative. That means if we distribute that to anything on this side, this becomes a positive. Whenever I do that, just pay attention to this part. Make sure you change this, once you distribute it, change it into an addition. Because your brain, this is what happens with some of you. When you distribute the negative, and when you're combining stuff, you see this negative here, you think that you're going to subtract, but you don't, because you already distributed the negative. So do that, please. And let's rewrite the numerator. We have negative 2g and we have positive 3, so that becomes negative 2g plus 3. So we're done with step 2. For step 3, we need to simplify using giant ones, but we don't have any giant ones until we find our GCF here, right? So think about this. What number divides 2 that divides 3? 1. However, the leading coefficient has a negative, so I'm going to factor out a negative 1. So, what do we have left? Let's see, negative 2g divided by negative 1 is positive 2g. Positive 3 divided by negative 1 is negative 3. Bring the denominator over, 2g minus 3. Now, do you see the giant 1? Yeah, let's go to step 3. Giant 1, that leaves us with negative 1/2. There it is. All right. Are we done? No, what's our last step? I'm going to do that in blue. Excluded value. So what do I write, Brooke? With 2 equal to 0. Is that true, guys? No, I mean, it's true the step, but that 2 is not equal to 0. So what does that mean? No excluded value. You're like, that's it, Mr. Q? That's it. So before I move on, what is the only thing that you need to remember to do when you get to subtracting rational expressions? Talk it over with your neighbor. What is the only thing to remember to do when subtracting rational expressions? All right? Good? All right, let me give you one for you to do by yourself. I'm just going to crank it about half a notch. Yeah? So you should be able to do this one by yourself. Ready? Example omega cubed. X over x plus 7 times x minus 7 minus 7 over x plus 7 x minus 7. Copy that, and I'll give you some time to find that difference. Copy and all right, let's see. First step is to factor the denominators completely. What do you notice on this one, Valerie? They're the same and they're already factored. Okay, so we're done with this first step because we already have a common denominator. Okay. So in order not to rewrite all that, I'm going to go to step 2. I'm going to rewrite now as one fraction. So let me go this way. One fraction, x plus 7, x minus 7. Focus on the numerator. So what do I write for my numerator? 3 x minus 7. Very good. Did everybody see that? Why, Mr. Q? Because we distribute this to this and change this to addition. Yes? So that means x minus 7. Next, can we identify giant ones? No, unless I do what here, Alexa? What would be our GCF? 1, and we're left with x minus 7 over x plus 7, x minus 7. Hands, we got it to right there. Okay, good. Now we go to step 3. Do you see the giant 1? Yes, so that leaves us with 1 over x plus 7. Hands, have you got that by yourself? Very good. Excluded value. What do I write, Carlos? X plus 7 equals 0. Then you solve by inverse operation, so you should have gotten x equals negative 7. Who got x equals negative 7 for the excluded value? Yeah, we got this, yeah? So once again, what is the only thing that you need not to forget with subtraction of rational expressions? Talk it over again with your neighbor to make sure they got it, please. What is the only thing not to forget, please? Yeah, and if you need to make a note for yourself, put a little asterisk, a heart, and then write yourself a note to not forget to distribute that negative and then change this to an addition. Please, pretty please. All right, we good? Yeah? Crank it up a little bit. Let's go. Copy this one. Example 1, x plus 5 over x squared minus 9 minus negative 2x minus 4 over x squared minus 9. So let's do this one together. First, we're going to factor completely the denominators. Look at the denominators. What would be the factor form of that denominator? Tell your neighbor the two factors for that one, please. Factors for that one. What do you think, Brooke? Factors of x squared minus 9. It's a difference of squares, x squared minus 9, so yes, x plus 3, x minus 3, yeah, and that's for both, x plus 3, x minus 3, okay? So do we need to do any multiplication? No, just bring down the numerators, x plus 5, negative 2x minus 4. Step 1, done. Let's go to step 2. Rewrite as one fraction. X plus 3, x minus 3. Alright. Focus on the numerators. So by looking at it, and your note that you made, yes, then you combine stuff and you write whatever is left there. Tell your neighbor what you're going to write here after you do whatever you need to do. What goes on the numerator? Tell your neighbor, please. Alright. What'd you get, Natalia? Numerator? X plus 9. Oh, 3x plus 9. Yes. Hands, have you got that? Yeah, that is correct. How did you get there? Well, distribute this negative here and here. Change this to addition. Combine 1x plus 2x, that's 3x. 5 plus 4, that's 9. And to identify the giant 1, we need to find the GCF here, yes? Norm, GCF here? 3, and we're left with x plus 3. Denominator x plus 3, x minus 3. So my giant 1, you guys see the giant 1 now? Yes, right there. So we're left with 3 over x minus 3. Not bad, yes? Excluded value. What would I write for my, to get started with the excluded value, Philip? X minus 3 equals 0, inverse operation, so therefore x equals 3. From 1 to 5, how comfortable you are with subtraction? Yeah, 4, 5, 4, 5. Yeah, we've been practicing addition, so the only difference is that you distribute that negative, yes? Okay, I'm going to give you one almost exactly like this one, so you can do the whole process by yourself. Here we go. Example 1Q reads negative x minus 7 over x squared minus 25 minus negative 2x minus 2 over x squared minus 25. I'll give you some time for that. Copy and go. Alright, give me a second. So the denominators were the same, difference of squares were here, one fraction. And Ricardo says that for the numerator we get what? X minus 5. Let's find out. We take this, distribute, change this to addition, and combine. What is 2x minus 1x? That's 1x. What is negative 7 plus 2? That is negative 5. Hands, have you got it to right there? Yeah. What do we do next? Andrew. By 1, multiply. So it's x minus 5. We're left with x plus 5, x minus 5, and now we can see the giant 1. So we end up with 1 over x plus 5. And have you got that? Okay, good. What you get for your excluded value, Thomas? X equals what? Negative 5. How do we get there? X plus 5 equal to 0, inverse operations, and there you go. Alright, from 1 to 5, how comfortable are we with these, yeah? Yeah, 4, 5, 4, 5. We good, yeah? Crank it up. Yeah, like 3 notches, yeah? 3? Let's go. Copy this one, please. Example 2. 3 over x minus 5 minus 1 over x squared minus 7x plus 10. Alright. So we're going to do this I'll get you guys started. How about that? There you go. Bam. Jessica, can we factor the first denominator anymore? No, so that stays the same. Okay. All right. Can we factor the second denominator, Valerie? Yes. 10 and -7. Okay. So what factors of 10 add up to -7? What two numbers? Tell your neighbor, what two numbers multiply, give me -10. When you add them, give us -7. All right. Dana, what numbers? -2 and -5. Hands, have you got those? Can we use a shortcut? Yes. X minus 2 times X minus 5. Now that I have my denominators, do they look exactly the same? No. What do we do next, Rachel? This side times what? X minus 2. That is correct. So we multiply this top and bottom times X minus 2. Like so? Yes. And now we just bring down the numerators. Yes? This is a 3 and this is a 1. Okay. All right. Step 1 is done. Woo! Let's go. Step 2. Write it as one fraction. X minus 2. X minus 5. All right. Focus on the numerator. Aww. So, we distribute. Bam, bam. What is that, Miguel? Three times X is 3X, -6, yes. So far so good, yes? How about over here? What would I write here, Noor? -1, yes. So this times that, yes, okay. So now that we have this, 3X, let me write it, 3X. What is -6 and -1? -7, yes. From there, I'm going to check with the GCF, which is 1. That leaves us with 3X minus 7, X minus 2, X minus 5. Are there any giant ones? No, so I'm done. Excluded values. Tell your neighbor what to write to get started with the excluded values, please. What do I write, Sky? Oh, X equals +5 and X equals +2. How does she get there? X minus 2 equals 0. X minus 5 equals 0, and then inverse operations, and there you go. All right, show me the figures. How come you are with these? Yeah, 5, 5, 5, 4, 5, 4. Yeah. It's just a little bit more robust. Yeah, it's got more stuff. Crank it up about a couple notches. Yeah. All right. Here we go. Example 3. X squared over 4 minus X squared minus 1 over 2 minus X. Factor completely the denominators. First of all, do you guys notice anything on the denominators? Yeah, what do you guys notice? Lewis, do you notice anything weird on the denominators? There's a GCF, okay. But what else do you notice? Anything weird? Square difference, yes. Okay. What do you think, Brianna? Standard form, it's out of order. So, to put it in order, what goes first? Negative x squared plus 4. How about this one? Negative x plus 2. Alright? So, what would be a GCF for this first one? GCF. Go, Carla. Negative 1, that is correct. So I open a parentheses, that leaves me with x squared minus 4. So let's finish this one off since we already got started there. So, negative 1. What are the factors for this? Tell your neighbor, please, the factors for that, now that you see it. All right, go, Christian. What are my factors?
X plus 2 and x minus 2.
Yeah, x plus 2, x minus 2. Okay, thank you. So we're done with this denominator. It took us like 1, 2, 3 steps to get there. Okay, that's fine. How about this one? What would be my GCF?
Okay.
Close. Negative 1, because it's got that negative in the front, right? So that leaves us with x minus 2. Do we have identical denominators? No. So Raymond, what do I need to do to this one to make it look like that? Multiply times x plus 2, top and bottom, x plus 2. So now just bring down the original numerators, the x squared here, and the 1 right here. Alright, I'm going to go this way. So my step 2, we rewrite this as one fraction. So we got negative 1, x minus 2, x plus 2. And our numerators, notice there's nothing multiplying the x squared, that stays the same, okay. However, what does this become right here? What do you think, Vianney? What does this become? We got this negative 1, and then we've got this. I'm sorry? Distribute, and you get what? Negative x minus 2, yes. You guys see it? Yes? So if we combine this with these two, we should get x squared minus x minus 2. Okay? Next, Audrina, can we factor this? Yeah, negative 2, negative 1. What factors of negative 2 add up to negative 1? Negative 2 and positive 1. So my factors are x minus 2, x plus 1. So we bring over the denominator, x minus 2, x plus 2. Do you guys see the giant 1? Yes? Yeah, right there. So my my simplified fraction is x plus 1 over negative 1 times x plus 2. Whew, that was a long one, yeah? Excluded value. Tell your neighbor what to write to get started with excluded value on that one. What do you write? Alright, what do I write, Lewis? Negative 1 equals 0 and X plus 2 equal to 0. So, is this true? No. So, inverse operation. So, X equals negative 6. Stop right there. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Get those pop party signs back